of general relativity. It is why Penrose received the 2020 Nobel Prize in Physics, and it represents a specific, permanent, correct contribution to the physics of space-time. The Harlow-Hayden result and its connection to Hawking's framework, while Hawking himself did not contribute to the specific complexity theoretic arguments that have been central to the information paradox resolution, his specific framework, the semi-classical treatment of quantum fields in black hole backgrounds, the specific definition of Hawking radiation, the specific formulation of the information paradox was the essential starting point for all subsequent work. You cannot have the resolution without having the problem first articulated with the specific clarity and mathematical precision that Hawking brought to it. The no-hair theorem contributions. The specific result that black holes are characterized by only three parameters, mass, charge, and angular momentum, was developed by multiple physicists, including Hawking, and it remains one of the foundational results of black hole physics. The specific theorem that all other information about the infalling matter is lost to external observers in classical general relativity was one of the specific results that made the information paradox so acute. If classical general relativity predicts no hair and quantum mechanics predicts information preservation, the two are in specific conflict. The Hartle-Hawking no-boundary proposal, which we discussed in the quantum cosmology context, is Hawking's specific contribution to quantum cosmology. The proposal that the universe has no boundary condition in the past, that the Big Bang is a specific, smooth geometric feature rather than a singular beginning, remains one of the most interesting and most actively developed frameworks in quantum cosmology. It is contested, but it is a specific, mathematically sophisticated, genuinely original proposal that continues to generate research. Let me now address the specific question that his life's work was a lie. Framing is trying to get at the question of whether Hawking's most prominent public positions were misleading or wrong in ways that matter. On the information paradox, Hawking was wrong about information being destroyed. He was wrong about this for specific, principled, technically grounded reasons that followed from the best available theoretical tools at the time. He was not being dishonest. He was being a physicist, following the calculation where it led, defending the conclusion when challenged, updating when new evidence was sufficiently compelling, and continuing to work on the problem until his death. The specific concession in 2004 was a specific public acknowledgement of error that required intellectual honesty and intellectual courage. Not every prominent physicist updates their publicly stated positions when the evidence goes against them. On other public pronouncements, the specific warnings about artificial intelligence, about alien contact, about existential risks, Hawking was making specific extrapolations beyond his specific area of expertise. These pronouncements may have been right or wrong in various ways, but they were not scientific claims in the technical sense and are not the subject of scientific falsification. On the specific science of black holes, of cosmology, of the early universe, Hawking's contributions are specific, real, mathematically rigorous, and in the vast majority of cases, correct. The information paradox was the specific major exception, the specific place where he was wrong about an important conclusion, and even there, the framework he built, Hawking radiation, Bekenstein-Hawking entropy, is the specific foundation on which the correct resolution was eventually constructed. His life's work was not a lie. It was the specific, genuine, mathematically real work of one of the most extraordinary theoretical physicists of the 20th century work that advanced the field, identified the specific problem whose resolution required the most sophisticated tools in contemporary theoretical physics, and contributed the specific foundational results, Hawking radiation, the singularity theorems, the no-hair theorem, the no boundary proposal, that remain permanently part of the physics canon. Let me now tell you about the specific way that Hawking's error was not just personally wrong, but had specific consequences for the trajectory of the field, because this is where the story becomes most interesting. The information paradox, as Hawking formulated it, occupied theoretical physics for 50 years. The specific urgency of the problem, driven by Hawking's specific forceful advocacy for the information-destroying position, motivated generations of physicists to develop specific new tools and specific new frameworks aimed at resolving it. The specific development of the holographic principle, the specific development of string theory as a framework for quantum gravity, the specific development of the AD-CFT correspondence by Maldacena in 1997, the specific development of quantum error correction as a framework for understanding holography, the specific development of quantum extremal surfaces and the island formula. Each of these specific developments was, at least in part, motivated by the specific need to resolve the information paradox that Hawking had framed so clearly and argued for so persistently. If Hawking had concluded in 1974 that Hawking radiation preserves information, if he had seen the exponentially small correlations as evidence of information preservation rather than as negligible, the specific motivation for much of the subsequent theoretical work would have been different. The specific urgency would have been absent. The specific community of physicists focused on this specific question might not have coalesced around it with the same intensity. Hawking's error, his specific, persistent, technically grounded, wrong conclusion about information destruction, was one of the most productive errors in the history of theoretical physics. Not because being wrong is good, because being specifically, clearly, forcefully wrong about an important question, and being wrong in a way that identifies the precise location of a genuine conflict between two fundamental theories, is exactly the kind of scientific contribution that advances the field most efficiently. The information paradox, as Hawking framed it, was the specific question that demanded the development of quantum gravity. It was the specific problem that made ADS-CFT immediately recognized as important. It was the specific context in which the holographic principle gained its most compelling justification. And it was the specific challenge whose resolution, the island formula, the page curve, everything we discussed in the black hole information conversation constitutes the most important advance in quantum gravity of the past decade. Hawking's life's work was not a lie. It was the specific, honest, extraordinarily productive work of a physicist who found a specific, genuine problem at the heart of theoretical physics, argued for a specific wrong answer with specific principled reasons, and in doing so created the specific intellectual urgency that eventually produced the correct answer. In part two, I want to go deeper into the specific technical details of where Hawking's calculation goes wrong, into what the correct calculation requires, and into something I find genuinely moving the specific story of what it means in science to be brilliantly, productively, consequentially wrong about something important. His life's work was a lie? No. His life's work was science. And the specific difference between those two sentences is the most important thing the story of Stephen Hawking and the information paradox tells us. So we'd arrived at this place where Hawking's specific error about information destruction, the particular conclusion he drew from his 1974 semi-classical calculation, that the Hawking radiation is exactly thermal and contains no information about infalling matter, was not a mathematical mistake or an act of intellectual dishonesty, but a specific, principled, technically grounded, wrong conclusion drawn from the best available tools at the time, where the exponentially suppressed correlations that actually encode information